All right, welcome back everybody. We have just been working on the first part of our float code. We're just learning how to program the stepper motor to work. What we haven't done is we haven't actually checked for any errors. So I'm going to select the device here. I don't have an Arduino to plug in right now. If you have one, plug it in so it knows what Arduino you're using. Otherwise, I'm going to just select a device, Arduino. It doesn't really matter which one I use. Well, it does, but none of the ones we have. And then I've got this selected here, so now we can actually do a check. Without knowing which Arduino, it can't do a verification to see if it works. And let's see if we throw any errors here. Oh, okay, we got some errors. Oh, we got a lot of errors. Let's see, in one, oh, I see what I've done. So here I didn't use the correct name. Actually, let me zoom in some so you can see this a little bit better. I think that might be good. Let's see. Yep, that's good. So I didn't use pin here. I used pin up here. So I don't actually want to make these longer. So I think what I'm going to do is I'm going to get rid of the pin up here. 1, 2, 3. And make all of these pin. I don't want to add the word pin on all of these because it's going to make it go off the screen for me. I don't want that. So I think I'm just going to live without pin on all of these. All right, and then let's go ahead and hit verify on that. We should have verified a few times in the last video so that we could catch these mistakes right away and make decisions right away. But we're not too far in, so it shouldn't be too bad. See how we're doing. Once this is done, we're going to start working on doing the water out function. And it looks just like the water in, except in reverse order. Well, then I'm going to go ahead and start. We're still verifying your sketch. Thanks for your patience. I think I'm going to go ahead and start doing that while it's verifying. So I'm going to copy the water in function and hit paste. And I'm going to rename water in to water out. And then I'm going to come down. My first one here should be the reverse of the water in. So this first one should look like this last one. So high is good, low is good. Low, okay, here we go. So this one needs to go low. Whoops. Low. And then this one needs to go high. Awesome. So now that one matches that one. And then this third one here should be my second one here. So low, high, good. And this one should be low, high as well. And that one matches. And now I can kind of just follow the pattern from before. So if it didn't change, it changes. If it did change last time, it doesn't. So here, this one did change last time, so it stays low, high. This one didn't change last time, so it reverses high and low. And then now this one stayed the same, so it reverses, and this one just reversed, so it should stay the same, so high, low. Let's see how that did. High, low. Yep, that's our first one up there. Low, high, low, high, low. Then the third one was low, high. So my second one, low, high, low, high. Because the last one, high, low, high. Okay. So these are the reverse of each other. So by running these sequences in reverse, it pushes it backwards. By running it forward, it pushes it forward. Yay. Now there is no real forward and backwards in a servo. So when I say it pushes forward and backwards, if when you do this code for the first time, if the servo goes in the wrong direction or a direction you didn't want it to go, all you gotta do is take out the 4 wires and flip them around, plug them in the opposite way. Kind of like the ESCs where you can flip 2 of the wires and reverse the motor. The same thing's true for a servo motor. I can't tell you enough that that's usually not the case. With motors, it oftentimes is though. All right, so let's see. I think that's everything. So we're good. Now we need to build up code that's going to start controlling the float. One of the problems right away with stepper motors is that they don't know where they are in their rotation. They're really good at very accurately moving small distances and just zipping around a small distance, but they don't keep track of where they are on their rotation. So if you turn them off and you rotate them, when they turn back on, they're just going to assume they're at the starting position, whatever that means. So inside your float, we need to find a way to actually have it to know where the servo motor is at some point. It's called homing it. So you may have seen on a 3D printer when the printer when it starts up will the head will go all the way to the right, and it actually clicks onto a little switch, and when it hits that switch, now the stepper motor, now the microprocessor can say, okay, the stepper motor is at this location in the world. And it might even do that vertically and forward, back, and all that stuff. It's called homing, like finding your home. We need to do that for our float. Let me grab the thing real quick and I'll show you what it looks like. Okay, so I've got my float here, and you can see that as this piece unscrews and draws water in, it's going to actually at some point bump into this little switch. And I'll have this wired to my Arduino so I can tell when this switch is triggered. So right when it's triggered, I'm going to tell the motor to stop, or I'm going to stop spinning the motor, and then I know that the motor is way up here somewhere. Then I can figure out how far I have to push it down from here to get it mostly back all the way in. I don't ever want to get it all the way in, because if it hits the bottom and can't go any further, the motor will get stuck trying to go further and burn up and have problems. So I'm just going to get down close. So I've got those two things to do. First of all, we need to pull the plunger out. So like draw water in until it hits this switch, and then we need to push the water back out until it gets down to a point where we're comfortable. And that's just got to be trial and error. We're going to try some numbers and see what happens. Now, as we're doing this, one thing you can do is as you draw water in the first time, it's going to have air all the way through the hoses. It's going to draw air in it first. So you can do it just like a doctor does. You can let it draw all the water in, and then flip it upside down, and as it pushes, that way the air will go to the top. As it pushes it back in, it'll be like a syringe, a doctor pushing the air bubble out, and it'll squirt water out. Once it squirts water out, you know it's totally full of air. You can flip it right back side up. Yeah? So that's what we're trying to do now, is create that homing function. Okay. All right, everyone, so here we go. Let's get started. You should have wired the, if you count time and do it that's okay. Just wire your limit switch and your motor and your motor controller so that we can actually play with it and push the buttons and do things to make it start and go and do different stuff. All right, let's rock and roll. So first thing we want to do is we want to actually read the limit switch. We want to read whether this thing has been pressed or not. If it hasn't been pressed, which hopefully it hasn't, that just means the plunger is down here somewhere. We don't know where. So the first thing we need to do, if this hasn't been pressed yet, is we need to have this thing draw water in until it does actually press it. Because once it does press it, we know where it is now, and then the microprocessor can figure out how far down to push it. All right. So to do that, we're going to use what's a digital read. And the reason we're using digital instead of analog read is there's only two values that could be. It could be either pressed or not pressed. And before we do this, we're going to have to do some other work as well. So we need to read a pin. So we need to figure out what pin we're putting it in. So I'm going to come up here and create a variable up here. And these are all my pins up here. So I'm going to put it with this group here. So I'm going to create an integer, and it's going to be I'm going to call it limit switch pin. And whatever pin you're going to put it to. So I'm going to put an asterisk there. You choose whichever pin you're wiring it to. It doesn't really matter. You don't need one of the PWM pins for this, so I wouldn't waste one of them on this, because you might need them for something else. And this is just a variable for the limit switch pin. Awesome. I'm going to copy and paste this variable here. Oh, be sure to leave yours an asterisk or you'll throw an error on that. It's not supposed to be there. I'll change mine later. And I'm going to digital read that pin. Now, of course, put in a semicolon. Of course, Arduino is really dumb, and it's going to forget that value right away. It's going to either read it as high or low, 0 or 1. We need to store that somewhere. So, okay, I'm going to come over here and say limit state, or let me go limit switch state equals, and once I get that equals in, it knows that this is going to be, oop, I misspelled switch. Limit switch state is the name of my variable. So now I'm going to go create this variable, which we just did once. So I need to declare it up top. Control C. I'm going to come up here, and I'm not going to put it with the pins. I'm going to put another extra space in and start making a value to store this in. And this could be an integer value, and it is Control V, limit switch state, and I will start it out at 0 or low. Let's do it low. Arduino knows that the word low also means 0. So you could do 0, 1 here, or low, high. You could also do true, false, which is kind of weird. Okay, and then this is a stores the last read limit switch state. And that's either low or high. All right, now we're going to actually need to declare this as a pin mode as well. So let's go ahead and do that because we're using a new pin. And this time we're going to declare it in a little bit of a weird way. So I'm here in the void setup underneath my other pin modes. I'm going to type in pin mode, and I'm going to put the limit switch pin in because that's what's controlling where it is. And now I'm going to do something else, and I'm going to do something called a pull up. And I'll tell you what that means in just a second, but let's get the code in. And it's typed in all caps, input, just like we normally would, except we're going to do underscore and then the word pull up, all in caps. P-U-L-L-U-P, all in caps. Semicolon to end it, slash, slash, and this makes not pressed, high, and pressed low. So when you do input pull up, what Arduino does is a really strange thing. It's going to take the limit switch pin, whichever one it is for you, and it's going to, Arduino's going to keep that pin high. So it's going to send a few 5-volt electrons to that pin to make it always read high. And the nice thing about this is that sometimes you'll get noise on a pin when you leave it low, because Arduino's not doing it, it's just ignoring it. So if there's a nearby voltage, sometimes you'll get a spike and you'll get an errant read of a button. It'll seem like it's high when it's not. But when you do input pull up, Arduino keeps enough electrons going to that pin that it keeps it pegged out at high the whole time. And the interference won't make a difference with it. At least small amounts won't. So it's kind of a safer way of doing things. To get the button pressed, what you're going to do is connect the button back to ground. So whenever you push the button, you're just going to basically ground out that pin, and now shift it down to low. And it'll do it really reliably down to low. So this is what it looks like. So nope, our logic is backwards. If it's high, it means it's not pressed. If it's low, it means it is pressed. Oh, so confusing. All right. So let's come back down here and say limit switch state equals digital read limit switch pin. So this reads the limit switch state. Okay, and maybe reads the limit switch state, and then I'm going to say here pressed is low. I'm not going to put any more because I don't want to break that line. I don't like having to go to another line. All right. So I'm going to leave that, assuming that not pressed is high then. That's just to remind me. Okay, so if we're not pressed, let's remember what that means. If it's pressed, we know we're all the way up here and we do not need to bring more water in. We need to go the other way. But if it's not pressed, we still need to move up some until we get there so we know where we are. So that's what I'm going to do here. So I'm going to create an if statement. Well, let's do a while. While. And we're going to take this variable that's storing our value for the limit switch state, and And we're going to say while limit switch equal, and then we're going to say high, meaning not pressed. Okay, so while it's not pressed, and then I'm going to put in a curly brace to open the while loop. Boom. And what this is, instead of using an if would cycle through and do everything else. This while is going to trap us in this loop until we hit a limit switch of low. So until the limit switch gets pressed, it's going to do whatever's in this this group. So what we want to do here is we want to draw this water in. So bring the plunger up and draw water in. So I'm just going to do a water in call. And just like that, we have a call. Now this, what it does when it sees water in with a parentheses like this, Arduino knows by the parentheses that this is a function. So it goes back up and looks for a function and says, oh, here's water in. It does these like lines of code. So it runs through these lines of code just once, and then it comes back and picks up wherever it left off. So this is gonna draw a small amount of water into the syringe. All right, we're almost there. So we're drawing water into the syringe, and it's just going to keep going over and over again. Boom, 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 over and over and over again. And yeah, that looks good. All right, so the only problem with this is a really common mistake with while loops. Notice I'm not rereading what the button is saying. I'm not seeing if the switch is still saying high. So this is actually going to just keep going forever because this is a value stored in a limit switch state. It doesn't know to go check stuff. So what we're going to have to do is take this digital read, and we're going to need to put this line of code inside the while loop. I'm going to put it right after the water in. So we say water in. It does one tiny little 3.6 degree. Then it checks the limit button to see if it's been pressed yet. If it has been pressed, it's going to leave the while loop. If it hasn't, it's going to do the loop again and bring in a little bit more water. So it's going to do one little tiny turn and then check the button, check the button, check the button, or check the limit switch, I should say. All right, so that part's really good. And then the last thing we want to do is we actually want, well, let's not do that yet. All right, so this is going to pull us all the way in. All that water is going to get pulled in. We're going to hit the limit switch. Then we need to actually drive the water back out because now we know where we are. We can actually know how far we need to go. To do that, we're going to do a for loop because we've got to do a bunch of water out to get back all the way to the bottom of the syringe. So for, and this is integer I equals 0. So that we're creating a variable for counting with. And we're setting that variable to start with 0. We want to keep going for some amount. We don't know yet. We're going to keep repeating for less than, I don't know, let's try 500 water outs. One little thing each, semicolon, I plus plus. 500's not super far, but we don't want to overshoot and have the plungers crash into the bottom. We want to bring it down to here somewhere, and then we'll just keep increasing that number trial and error until we get close but not touching the bottom. All right, and then we're going to go for loop, curly brace, enter. Now, whatever we put in here is going to get repeated 500 times. So what we want to do is we want to push the water out. So we want to do water out, here, semicolon, and then I'm going to actually just copy and paste this one up here and put it here, and this expels a small amount of water out of the syringe. Awesome. And here we don't need to read the limit switch because we're not using it anymore. We're going back down so far. We're going to have to figure out what this perfect number is to get us close to but not at the bottom of, and that's just going to take a little bit of time. All right, my friends, I think let's do one quick error check before we move on, just so we can fix the errors before we leave. See if it's working again. Yep. Oh, error. Let's see. Error. Expected primary expression before blank token. Int limit. Oh, this is my... I gotta choose one. I don't know. I'm gonna put pin 4 for now, but I might change that over time. I haven't actually looked to see what it actually is. Let's do that real quick. Hopefully you didn't throw that same error because you put a number in for yours. Another one. Error. Digital read was not declared in this scope. Oh, I misspelled digital. So it thought it was a variable instead of digital read. There it goes. Lots of little errors. Oh, another one. Oh, I think I copy and pasted this digital read, so it's the same error down here. Should have thought about that for a second. All right, we're almost there, sorry. If your code, passed, move on. All right, that's it for me, my friends. Have a good day, and we will see you in the next video.